Cool. Thanks. Yeah, my audio may be choppy occasionally. Please just let me know in chat and I'll repeat stuff. But thank you very much for having me. And real quick plug for my employer. We are a drop-in user data store, free as in beer, not totally open source, although a lot of stuff we do is Apache license. We support things like OAuth grants, SAML, passwordless authentication, and more. And we do produce a lot of JWTs, which is basically what a JSON Web Token is, which is what this entire talk is about. So I won't mention anything else about Fusion Auth except for kind of adjacent to actual real content, but they do pay me, so, and I like to eat, so I figured it was a good thing to throw out there. About me, who cares, really? You all are here to learn about JWTs, JSON Web Tokens, not about Dan Moore. If you have questions, again, I already mentioned, put them in the chat so I can see that. And I'd love for this to be more of a discussion than for it to be me just talking at you. Zoom is weird, so again, please feel free to type something in chat. If I make an outrageous comment, or I say something dumb, or I say something that you're curious about, please chat. So this talk is really focused around JSON Web Tokens. There's some Ruby and some Rails, but they tend to come towards the end. So you will get some Ruby, and we'll actually look at some code. Real quick, JWTs are JSON Web Tokens. They're an IATF standard, and they're a stateless, portable way for you to represent user identity. They're great for APIs because you can generate a JWT and pass it to your APIs, and your APIs can know, can I do that? Can I allow this user to do this? Can I allow this user to do that? Without calling back to the main user data store, and we'll see how that works. They're produced by a lot of IDP or identity provider servers, and an important thing to realize about JWTs is that they're base64 encoded, so they look like gobbledygook, but it's really easy to turn them back into intelligible person readable strings. And the reason they're base64 encoded is because you're passing them around a lot into HTTP headers or other places like that, and it's just simpler if you don't have new lines or curly braces or anything like that. All right, so let's kind of walk through kind of the use case, right? So here's the use case: is we have a application, we have a user database, right? And that's fronted by a user API. We have a to-do API, which is fronted, which has a to-do database, and then clients are accessing both of these. So the user API, this is probably pretty standard. Hopefully you've all seen this before. Users, user roles, and roles, right? So we have a way to map users to certain roles. To-dos, basically they're just a list of to-dos. And so this might look like something like this, right? Where it's just an ID, text, and then each to-do is associated with a user. And so in this case, it happens to be an integer, but it could be any way of referencing a user. So let's kind of walk through the scenario here, right? I'm a client, a mobile device or a browser, and I have got the user authentication information, username and password, and I post that to a login endpoint. And that goes against the user API. The user API checks to see, oh, does this match, right? Hopefully the passwords are not stored in plain text. Please don't do that. Anyway, it verifies that the user is authenticated and passes back an object for user ID 42, right? And so this is going to be in JSON, and it might look a little something like this, right? It might have an ID, a name, other identifying information. It could have roles that this user is allowed to have. So now that we have this user object, we want to get the to-dos of this user. So the user object is stored on the client, and it makes a call to the to-dos API, says, give me all the to-dos for this user ID of 42. The to-do API goes against the database and then binds them and sends them back. So does this raise anybody's, does this worry anybody? Is there any problem with this scenario of the client just passing in the user ID and getting back the to-dos for that user. You can put it in chat, you can unmute it. There's no auth. Yep, Aaron hit the nail on the head. You can pass user ID equals 43 to get another user's to-dos. Exactly, dangerous, right? So a malicious client could craft or could suss out that the user ID is not being validated and go ahead and look at anybody's to-dos, right? And so, you know, to-dos should go get some milk from the store, then I shouldn't have to worry about anybody else finding that out, right? So, am I back? Okay. Audio's choppy. Still choppy. Okay, a bit. Okay, well, thank you all for being patient. If words are missing, please let me know. So yeah, so we have this user API, and when the client makes the request and gets logged in, the user API creates a token, passes the token to the client. The token then passes it back to the to-do API or any other APIs, and the to-do API says, okay, I have this token that's opaque to me. I don't really know what's in there. I'm going to ask for user information from the user API. And it makes a call, and then we have assurances that a malicious client can't go ahead and look at any to-dos. Now, at the very least, we can be assured that because we control both the user API and the to-do API, we can be assured that that token represents a real user who's really been logged in and is not being crafted. The problem with this structure is that you have to manage between users and tokens. It's also very chatty because basically every time you have to talk to the user API, which means that the user API is going to be getting a lot of requests saying, hey, who is this user? Tell me more about this user. What can this user do? Give me the user object back. And that coupling is not necessarily good for scaling. So what we can do is JWTs ride to the rescue. So the user API creates a JWT, a JSON Web Token, and passes that to the client. The client then passes it back to the to-do API. And here's the big win for JWTs is that the to-do API can examine it and know that it hasn't been changed over the wire, that's a valid JSON Web Token, and it can examine the innards of it without actually talking to the user API at all because of the way it's been encoded and can be decoded. So it has additional other benefits. You can actually sign them with a public-private key pair instead of a symmetric key, and we'll talk about why you might want to do that. You can put whatever you want into this JSON Web Token. So that would be, you know, we already saw that you might want to pass roles down as the user object. You could pass things like favorite football team or anything else that's application specific, right? For this to-do application, you might pass down whether someone's a premium user or a free user, and then offer different functionality based on that. The one thing I want to kind of emphasize over and over again is don't put secrets in your JWTs. And the reason why is that you can, we'll break it apart in a little bit here, but it's basically a base 64 encoded string. And the way that it's signed means that you can tell it hasn't been tampered with, but you're not protecting what's in there. And so I can show you, if we have time towards the end, any JWT that you can get access to, you can plug into any tool, a bunch of tools out there on the internet, and see what's in the payload. So don't put secrets in there, and don't put anything that might bleed a little bit, right? So something could be not secret, but not necessarily something that you want known to attackers. And in that case, don't put it in your JWT. So this is the big reveal. This is a JSON Web Token. Can you all vote? I don't know whether you can do thumbs up, thumbs down. I'm curious how many of you actually interacted with the JWT before. If you can give me a thumbs up, I think I can see that. Got 1, 2. Oh, I like that. That's not a virtual thumbs up. That's a real thumbs up, Andy. Thank you. 3. Great. Okay, cool. All right. So some of this stuff for the people who've interacted with this might be a little bit of a refresher course, but I think there's enough people that I want to kind of dig into kind of the nuts and bolts of it. So basically, a JWT consists of 3 clauses. There's a header, which is this green section, the payload or the body, which is the blue section, and then there's the signature, which is the white section. So the header includes things like the algorithm that was used to sign the JWT and what the type of the token is. I've only seen that be a JWT, but I think you could do other ones. The body is really where the action is, right? So this is base 64 encoded string, which if you base 64 decode it, you will see this JSON object. And you can put anything you want in a JSON in a JSON object. Excuse me for a second. And the keys of this JSON object are called claims, and some are standardized, and these are mostly standardized, and then some are arbitrary, right? So they could be things that are specific to your application. So let's kind of walk through some of these standard claims. ISS stands for issuer, and so this tends to be some way of identifying the user data store that generated this JWT. EXP is the expiration time, and so this is the number of seconds into the Unix epoch that beyond which this JWT is no longer valid. So it's a way for you to, because it's stateless, because you're not talking to the user data store, you need some way to say, hey, this JWT is no longer valid, and time is a major way to do that. The AUD claim is the audience, and so this is a string or an array of strings, and this basically says, hey, this JWT was built by the ISS, by the issuer, for this audience. And so you could imagine if you have a you have a user API, you have a to-do API, and you might have an email API too, right? And so you might issue a JWT that's only good for the to-do API. And if the email API receives it accidentally, the email API shouldn't think that it's valid. And you would do that using the audience claim. You would say the audience is this is for the to-do API, not the email API. And that does put some burden on the consumer of the JWT, right? The various APIs, they're also called protected resources. But if you want additional levels of kind of separation of concerns, you can do that. The sub claim is the actual user that this JWT is for. And then we have other claims like name and roles. One thing that's worth noting here is that the odd and the sub are both GUIDs, right? And the reason for that is actually an implementation detail of Fusion Auth. It doesn't have to be that way. It's not in the specification. And the reason for that is that we don't want, if we just use kind of IDs, then that would be a leaking some information, right? If the ID of subscriber Dan Moore is, or subject Dan Moore is 122, well, that tells you something about, well, what's 121? What's 120, right? Maybe those are interesting things to an attacker. Finally, we have the JWT signature, and this is going to be a cryptographically signed just base64 signature, base64 encoded signature. And this is what any JWT library is going to do, is going to check to make sure that what it received is what the identity provider or the user data store generated. So finally, you actually have this JWT and you're the to-do API, and you basically decode it, and it's valid, right? It hasn't expired, the signature is valid. So you say, okay, cool, I actually have a user ID. I'm gonna go ahead and go look up their to-dos and send them back. So scenario one was the passing the ID in the get string, that's bad. Scenario two was the kind of opaque token, which had its benefits, but because it was simpler, but also meant that you constantly were talking to the user API. And scenario three is the JWT. Now there are some issues, like with any standard, there are some issues. The JWT specification actually allows for you to not sign the JWT. And so that would take a JWT that looked like this and make it look like this. So the header changes because we've changed our algorithm. So we go from this header to this, where the algorithm is none. And you can see that there's no signature. So there's no third clause. The payload stays the same. The JWT specification allows this. And curious if anyone had some thoughts on why that might be a bad idea. See how interactive I can make it on Zoom? Any thoughts? Exactly. So Ross said spoofing, and the exact thing is that you don't know that client, or sorry, you don't know that JWT came from the issuer that it said it did, right? You could have a malicious client make it up. They might even talk to the user data store. They might just make up a JWT and send it to the to-do API and get access to all those to-dos. So the simple fix is don't ever allow none as an algorithm, right? Don't accept it as a protected resource. Don't ever generate it as from the user data store. Now, I used to be a consultant, so the answer to any question a consultant asks is never yes or no. It's always it depends. So there is a case for a JWT of algorithm none. It's where you have something that's highly performant. You're generating a lot of JWTs, or you're consuming a lot of them, and the cryptographic signature that you have to make, or the cryptographic check you have to do to verify a signature is going to impact performance. And you have some other way to verify that the JWT is unchanged, or you trust all your clients absolutely. An example of that latter case might be if you have client certificates and server certificates and you're doing mutual TLS verification. In that case, you know who your clients are, they're not going to try to spoof things, or maybe you do trust that, and then you can conceivably use the algorithm in them. But it's just generally safer unless you're in like a very specific use case, in which case you're probably not attending a intro to JWT talk at a Ruby meetup. You're probably in probably better off just saying don't use none. All right, so let's talk about RSA verification. So, and this is more generally, this is any kind of public-private key signature validation. So we might have a situation here where the user API is managed by one group and the to-do API is managed by a different group. And if they have a safe way to exchange secrets, then using a symmetric key like HMAC might be a better option. But if they don't have a great way, right, maybe they're not in the different groups, maybe they're in different companies, and you just happen to you have a contract to allow the to-do API to be accessed by people who've been authenticated by someone else in a different company. In that case, you can't share a secret, or it becomes cumbersome to share a secret. And so in that case, you can actually use public-private key signatures. And what happens then is the user API signs their JWT with a private key. They publish the corresponding public key to a known location. They send that JWT down to the user client, the client sends, so Andy asks, what is the advantage of HMAC? You mean, Andy, as opposed to using public-private key all the time?
Yes, correct.
Cool. Performance. It's just faster to do. I mean, and this is just generally true, right? For all cryptography, it's faster to do symmetric encryption and decryption and signing. And basically, any symmetric operation is going to be faster than a public-private operation. Yep. Cool. Great question. So the client has sent the JWT up, and the JWT has specified that it is been signed with a RSA algorithm. So it says, oh gosh, I need to find out where this public key is. And you can have, the user API can publish its public keys in a well-known location. I think this is the Fusion Auth location. I'm not sure this has been standardized, but it pulls in that key, that public key, and then it can validate that this JWT was signed by the corresponding private key. And so that lets you, and you can have multiple different public keys, right? Here's an example of what a public key would look like. You can have multiple keys. I jumped ahead of myself right there. And those you just specify in the JWT header, in the JWT header, so that the client can say, hey, I'm going to match up key ID. This JWT was signed by key with ID 42, so I'm going to verify it with key ID 42. And again, this is all just kind of JSON objects. Any questions about what? So I mean, the big reason why you wouldn't use public-private key is performance. The big reason why you would is it allows you to not have a shared secret, and that might be really important if you're kind of rotating keys regularly, which is an option as well. Any questions about that before I move on to refresh tokens? Cool. As someone said, silence is assent. All right, so refresh tokens are a way to deal with the situation where you might want someone to be able to say logged in to your API or have access to your API for a long period of time, right? Especially if it's something like a mobile app that is pulling to-do information. But JWTs are really supposed to be short-lived. And they're supposed to be short-lived because revocation of JWTs is hard. And we'll talk a little bit more later on this in this presentation about how you can revoke JWTs. But if you keep the timeline short-lived, then that means when you want to revoke them, you don't have to work that hard. Or conceivably, you could just wait and let the JWTs all expire. So refresh tokens are a way that you can create, basically present a token to an identity server and get back a new JWT. How does this actually work? Well, it's something like this, right? So the user API creates a JWT and a refresh token, sends them both down to the client. The client uses the JWT against the to-do API many times, and then eventually the JWT expires, right? Maybe in 5 minutes, maybe in 30. And then the to-do API says, whoa, guy, hey, this JWT is no longer valid. Go get me another JWT or you're denied access to my API. The client says, okay, cool. My JWT is no longer valid. I'm going to go back to the user API, present my refresh token, and the user API can then validate that this token is still okay and send down another JWT. And then the client then sends back that new JWT to the to-do API, which is now happy and can let you do all your task management. So that's what client refresh tokens are for. If you are interested in deleting users, again, in this kind of distributed environment where you don't have a single database, this statement no longer works, right? Or it works within the user's API, but there's no cascade. There's no ability to run a on-delete cascade, right? So that means that you're going to end up with to-dos that are stranded, that aren't really associated with any other, any user. And that's a problem because, well, one, there's a little bit of space issue, but that's not too big a deal. there's some rules. You guys might have heard the general data privacy, no, general protection, GDPR. I always forget what it actually stands for, but that means that you need to be able, if you serve any customers in the EU at all, you need to be able to delete their data. And you also want to think about, I think this California passed a similar piece of legislation recently. So I believe that. Ross says he believes it stands for pain. Yes. I think that might be the colloquial name for it. Your options for deleting things are, you have a couple options. One, which I don't find to be super satisfactory, but can work for smaller systems, is the client just calls delete everywhere, right? So you basically are saying, I want to delete user Dan Moore. I'm going to delete him out of the user API. I'm going to call the to-do API with a user ID, and the to-do API is supposed to be responsible for that. That puts a lot of weight and a lot of burden on the client to make sure it's calling into all of the APIs where there might be user data. An alternative is to have the server-side stuff take care of it. And so in this case, the to-do API is going to, when it says, hey, I want to start to receive, I'm launching, I'm integrating with this user data store, I'm going to register a webhook and a webhook endpoint with the user API. And so now I can listen for events that are useful to me. One of those might be the user is deleted. When the user gets deleted, the user API fires that webhook with that sub ID, and then that gets passed to the to-do API and crucially, any other APIs that have registered with this data store, and then they can do that delete, right? So you're taking the burden off the client and you're putting it onto the servers, basically the services. All right, so now let's talk about revocation. So we're gonna talk about logging people out. We're not talking about a Megadeth album. I had to look this up. I didn't realize that I'm not a heavy metal fan, but the person who created this presentation was, apparently. So when you log out, you want to make sure you destroy the JWT on the client. You want to make sure you destroy the refresh token on the client, and you want to make sure you invalidate the refresh token in the user API. Does anyone see anything that might be missing or might be concerning that's not taken care of? Oh, Aaron was saying you did this with message queue. I'm sorry, I missed this. Wait, when you said you did this, you meant the delete you did with the message queue? Yep. Yeah, you just need to have some asynchronous way of doing this, right? Because you don't want to put the effort on the client to remember all the different APIs, right? It's much better to have a central choke point and you know, fire off and just say, hey, when you did it with a queue, what did you have multiple different queues, for one for each API, or did you like have it on one queue and then like you use like a topic to broadcast out?
Yeah, we have one queue that each consumer that needs to listen to it would pull from.
Yep. So that's just another way of saying webhook in a probably a more tech forward way. But yeah, message queues would work great too, for sure. All right. So more about logout. So in this case, is anyone disturbed by the X's here? Is there anything that's missing that we're not taking care of that might be worrisome? Everything's okay? Everything's thumbs up? Thank you, Andy. The to-do API will still accept the old JWT as long as it has not expired, right? So the client has deleted the JWT or marked it or gotten rid of it, but there could be somebody else out there who has noticed that this JWT is still valid and was watching something, watching the client or some bad thing on the client device, right? Could have been monitoring things. So we'd want to have some way to remove the JWT. first step is to make sure that you log out of all of the refresh tokens, so that you're removing all the refresh tokens, because if a refresh token is still extant or is still valid, then that means that a bad person, a malicious actor, can actually take that refresh token and get a brand new JWT. So first thing to do is get rid of all the refresh tokens. Now we're going to talk about revoking JWTs. So there's a couple of options. The first option, which I didn't actually even put in slides, is you can just make your JWT lifetime short enough that you're like, well, it's unlikely to do data isn't that important. 5 minutes, of someone being able to possibly get access to it, we're going to be okay with that. Your data needs better than I do. That's not a typical answer, but it's definitely one that you could do. But let's say it's something that's worse, right? Like we're actually really worried about this. A user's account has been breached. They've told us that it was breached. And so now we want to make sure that all their JWTs are no longer valid because we're protecting their to-dos. Bad juju. So the first thing you could do, the first option to actually really deal with the security hole, is to rotate your keys. And that's kind of a thermonuclear option. You basically, any JWT that has been signed or been has used those keys to be signed is now invalid. And in some cases, if there was a substantial breach, that might be a very worthwhile thing to do. But you might want to have an approach that's a little more granular. And so a way to do this is the time window solution. And this is a little complicated, so I'm going to kind of walk through a little bit slowly, but please let me know if it doesn't make sense. So the idea is that the To-Do API gets a notice, not just when a user is deleted, but when a user's token has been revoked, when the refresh token has been revoked, which basically means they've logged out. So that To-Do API now will be watching for those, and then it will be able to say, okay, any token with this user that was issued before this refresh token revoke event happened is invalid. Let's break that down a little bit. So let's say it's May 9th, 2020, and that's when the user says, hey, my password was breached, and I want you to revoke all the, well, they won't say because they're client worried about to-dos, but your security team says, now we need to revoke all the tokens for this user because their account's been breached. So it's 1:12:47 in the afternoon. So a new JWT created right now will expire in 30 minutes. Let's just say that's the standard. It can be whatever number you want, but for this example, it's going to expire in 30 minutes. That means that a JWT created 1 second ago, just before we were informed by about the breach, will expire at 1:42:46. That means that all JWTs that expire on or before 1:42:46 should be invalid, because those are all the JWTs that were possibly created before we were informed of the breach. So basically what we're doing here is we're dealing with this red area, because, like I said, the first option is you just accept that the red areas, you're going to have possible invalid or malicious access. But we're basically saying, okay, anything that is before this 1:42:47, we're going to treat as an invalid JWT. And the way you do that, to be frank, is you put intelligence into your client, right? Not into the client, I'm sorry, into your resource, right? Your API, your To-Do API, your email API, those now need to be smart enough to take that revocation event and say, okay, cool, for this particular user, I'm going to now know that any JWTs that were created before this point in time are invalid. Does that make sense to everybody? All right, silence. Sounds good. Okay, let's go ahead and jump into some code real quick. I think I need to stop sharing this and share the other screen. Share screen. All right. So basically, this is just a repo that I put together that is going to kind of walk through how you would create and I did not reset this. So this is basically going to be how you create or validate JWTs in Ruby. So this is the algorithm I told you never to use, right? So this is basically saying that we're going to use the none algorithm. And then on line 13, you can see our payload. And again, we could put anything in here we wanted, right? So we could put favorite team, and because I'm from Colorado, I need to put the Broncos, but I don't want to get lynched, so maybe I'll put the Chiefs. All right, so then we can do Ruby. Nope. Team Chiefs. That looks like valid JSON to me.
Is it the space between the colon and the key?
Thank you. All right, there we are. Cool. Thank you very much. So yeah, so you can see that we created this JWT. It doesn't have the signature, and it basically gives us back what we put in. Payload. Here's an example where we use secret to sign it. Again, this probably, you're not going to use something like this. It's going to be a long string of digits. It shouldn't be your secret key base in Rails. It should be a separate secret. And here we're providing it. And actually, in this scenario, basically, this is the user API, and this is the to-do API, right? API. So because I was lazy, I didn't break these apart into 2 Ruby files, but this is really how you use it, right? First, you're creating the token, and then you're decoding the token. So here we get the signature, get a lot more information, or not a lot more information, but we get the signature. Here, we're going to do the same thing with the public-private key. And again, you're probably, this is just for demonstration. In a real world environment, you're not going to be generating a new private key for each time you encoded a JWT. You're probably going to pull them from someplace else, a secrets manager or something like that. All right, cool. Next thing, so let's just say we're in the to-do API, and the server has rotated the HMAX secret, or sorry, the user API has rotated the HMAX secret, but we haven't actually done that yet. And so, or we have an old one. And let's see what happens here. Boom, the signature verification failed, right? And so this is something that you, if you're consuming a JWT, you're going to need to handle that with a rescue clause. And also, just to make sure I'm being honest, oh, wait a second. Okay, let's go back here. Live demos. All right, we're going to cut and paste this in here. Okay. So there we are. This is valid. Now, if any of these characters is changed, let's change it to by a malicious person or someone over the wire, then, oh, whoa. I'm in the code. Okay, oh gosh. There we are, boom, again, the signature verification failed. And then the last bit of code is, so this is kind of what I talked about. You can verify things beyond the signature. as a client, as the protected resource, as the to-do API, you can verify other things like who was this issued for, who was this issued by. There's other tokens like, there's actually a token called NBF, which basically, this is a claim called NBF, and the NBF claim says this token is not valid before this time. So if you wanted to issue a JWT and say this JWT is going to be valid from tomorrow at noon till tomorrow at 1, you can do that. The responsibility is on the consumer of the JWT to make sure they're checking that validation, but it's all standardized that you can do that. So in this particular case, I'm going to verify in the to-do API that my expected issuer is the user data store, the user API that I expect. And if I change this to here, everything's fine. But if I change this to hacked, boom, the issuer is invalid. And the way that this works with the JWT library is that I specify here in my options that I pass to the decode what things I want to verify and what I expect those values to be. So you could do this, again, you could do this with the audience. You could conceivably do this with the subscriber or the subject, right? Or certain roles. So you have some flexibility there in terms of what you consider, what you as the protected resource consider to be a valid JWT. And that's the end of the code. Any questions about the code? I guess I should have asked that while the code was still up, but any questions about the code? Awesome. Cool. So it's all available at this GitHub repo. So as far as kind of thinking about JWTs and Rails and JWTs and Ruby, it's really a question of kind of what are you trying to accomplish? If you're handed a JWT by a third-party SSO server or something like that, then you want to use the JWT gem to pull it apart, and that will take care of, the JWT gem by default takes care of expiration and signature validation. If you want any of that other kind of additional claims checking, then you're going to want to modify the options that are passed in. For authorization, if you're a protected resource, I just implemented this in a little Rails application. Basically, I just use a before filter, which takes this JWT apart, examines the claims, and then will either kind of throw a fit if it isn't a valid JWT, or will kind of let the request pass through if it is valid. I've read about devised integration. I've never actually done it. There's a couple articles out there for that, but I can't really speak to that too much. As far as tools, there's the Ruby gem. This is a JWT debug tool, and that just shows you actually how to, it basically just base64 decodes the JWT. And that's all I have. So I want to say thank you very much, all of you, for putting up with some of my Zoom stuff, but and also for the opportunity to talk to you. And I'm happy to hang out for a little bit. We can ask some questions. Happy to talk about Fusion Auth, happy to talk about JWTs, happy to talk about Rails stuff in general. So thank you very much.
Thank you.
Thank you.